Is electrolysis the key to understanding cold fusion energy? Imagine a simple science experiment turning into one of the biggest mysteries in physics. That's what cold fusion experiments have done, and electrolysis plays a big part in this puzzle. Electrolysis is when electricity splits water into hydrogen and oxygen gases. It's a common process in labs and industries, used to produce hydrogen fuel or purify metals. But in cold fusion research, electrolysis is more than just a chemical step. It's the gateway to strange and unexplained phenomena. Back in the late 1980s, scientists Martin Fleischmann and Stanley Pons used electrolysis with heavy water and palladium metal. Heavy water contains deuterium, a heavier form of hydrogen. They ran electric current through this setup, expecting chemical reactions. Instead, they claimed to see excess heat that couldn't be explained by normal chemistry. This excess heat suggested something else was happening, possibly nuclear fusion at room temperature. If true, this could revolutionize energy production. The idea is that during electrolysis, hydrogen or deuterium atoms are loaded into the metal lattice. Metals like palladium or nickel act like sponges, soaking up these atoms. Some researchers believe that, under these conditions, the metal might help hydrogen nuclei get close enough to fuse. Normally, positively charged nuclei repel each other, creating what's called the Coulomb barrier. But in these experiments, it's thought that the metal could somehow reduce this barrier, making fusion possible at low temperatures. Many experiments have tried to replicate these results. Some reported excess heat, others claim to see new elements forming, like calcium. But the results are often inconsistent and hard to reproduce. Some scientists argue that the heat might come from chemical effects or experimental errors, not nuclear fusion. The lack of significant radiation, like neutrons or gamma rays, also puzzles researchers. If fusion were happening, we'd expect to see high-energy radiation, but that's rarely observed. Electrolysis remains central because it's how researchers load the metals with hydrogen or deuterium. The process creates conditions that might allow nuclei to get close enough to fuse. Some theories suggest that the metal lattice could act as a shield, reducing the energy needed for fusion. Others think there might be unknown forces at play, making cold fusion a mysterious source of energy. Over the years, different setups have been tested. Some used palladium with heavy water, others used nickel with light water and salts. Results vary widely. Some experiments even report detecting new elements, hinting at nuclear reactions. But the scientific community remains divided because these experiments are difficult to reproduce reliably. In the realm of unexplained physical and cosmic phenomena, cold fusion is a fascinating case. It challenges our understanding of nuclear physics and the forces that govern energy. Electrolysis, a simple process, might hold the key to unlocking these secrets. Whether it's a new form of energy or just an odd chemical effect, it keeps scientists questioning what's possible. For now, it's a strange corner of science that invites curiosity and cautious investigation.